So ax squared plus bx plus c. The c value tells us our y-intercept. The other thing that we can see from standard form is the shape of the graph. So remember, a quadratic takes the shape of a parabola. And the a value tells us what that parabola is going to look like. If a is negative, so if we have a negative sign out in front of our a value, our parabola will be concave down. So it will be looking like this. So a negative a means we have a concave down. It flips it upside down. A positive a means it will be concave up, so like a facing up U. This goes back to sort of parent functions a little bit. If a is greater than 1, so if it is a value bigger than 1, you will have a vertical stretch, meaning the graph will be narrower than the parent function. So if you have like a of 5, the bigger that a value is, the more narrow your graph is going to get.
Like a rubber band?
Exactly. If a is between 0 and 1, so if it's like a fraction that's between 0 and 1, like 1/2, or a decimal like 0.7, between 0 and 1, we'll have a vertical shrink, meaning our graph is going to get wider. So a tells us a little bit how the graph is going to look, the sort of the shape of that parabola, and then c tells us the y-intercept. Okay, the vertex, as we know, is going to be the highest or lowest point on the parabola. We also know this as a max or a min. And we'll have a max or min depending on what shape that parabola takes. Is it concave up? It'll have a minimum. Is it concave down? It will have a maximum. Is an imaginary line dividing the parabola in half through the vertex? So all parabolas have an axis of symmetry because they mirror one another on each side. If you folded it in half, each side would lay right on top of the other side, right? So we have our parabola, we have that vertex, and this axis of symmetry cuts it exactly in half, okay? The axis of symmetry is always an equation, and because it is a vertical line, it takes the form x equals a value. We can find that value from standard form. We plug in the b value and the a value from our standard form to figure out exactly where that axis of symmetry will run. So x equals negative b over 2a. You will see your b value in your standard form, and you will see your a value in standard form. You just plug them in and simplify. What did you say? B is always negative, yeah, to start. Sometimes it'll get positive if you put another negative. Okay, so what we will use this for are questions like this: finding the vertex, the axis of symmetry, and the y-intercept of each of these functions. And then we're going to sketch a graph. So to start, let's just identify what is a in number 1. What's our a value? 3. B is what? Negative 6. And C is 1. So to start off, the first thing that I can see, that I can graph from standard form is what? The y-intercept, which is 1. So I can see my y-intercept because it's the same value as C. So I can go on my y-axis and I can plot that y-intercept right away. Then it wants my axis of symmetry. And I know that I find that by using x equals negative b over 2a. Yes?
What does A tell us again?
A tells us how wide or narrow our graph's going to be, and if it's going to be concave up, which would be a positive a, or concave down, which would be a negative a. Okay, let's plug in negative, and then my b value was what? Negative 6. So I have to put them both. I put my negative that's part of my formula, and then I put my negative 6 for b, over 2 times a, and a was 3. So then I simplify all this. Negative 6 becomes positive, and 2 times 3 is 6. So my axis of symmetry occurs at x equals 1. So I can kind of sketch this in here. I know that that axis of symmetry is going to divide my parabola in half. This x value is also the x coordinate of the vertex, because it goes right through the vertex. So when we find that axis of symmetry, we also know the x coordinate of our vertex. But we need to figure out the y coordinate. So like, where along this axis of symmetry is the vertex going to happen? Well, we take this x value and we plug it back in to our original. The value we get out is the y value. So if we plug in 1 for x into our original equation and solve, that will be the y coordinate of our vertex. Be super careful. You must do this first, right? Order of operations says we have to do the exponent first. So don't do 3 times 1 and then square 3. Instead, you have to do the exponent first. 1 squared is 1, times 3 is 3. What's 1 times 1? 1. 1 squared is 1. Then 3 minus 6 is negative 3, plus 1, negative 2. So when x was 1, y is negative 2. That is my vertex. I can plot that 1, negative 2, so that's here. And then I can plot a third point, because I know that this axis of symmetry has divided my graph in half. I know there will be a mirror point on the other side of that y-intercept. And then I can sketch my graph. Don't forget your arrows on both sides. And then it asks for domain and range. So let's do those two. What's the domain of any quadratic? Negative infinity to positive infinity. This graph is getting wider and wider forever. It will hit every x value if it goes on forever. The range is y values, low to high. The first y value that I have that exists is at the y coordinate of my vertex. And we include it because it is a line or a closed circle at that point. And then it goes on to positive infinity. See, where's the y-intercept of this function? Good. So we could plot that first. Y-intercept is at negative 1. Our axis of symmetry occurs at negative b over 2a. So negative b is what? This is b, so negative 2. What is a in this quadratic? 1. So negative 2 over 2, so my axis of symmetry is at x equals negative 1. So I will sketch that in over here. Then I need to figure out what's the y value of my vertex along that axis of symmetry. I take this negative 1 and plug it back in to my original. So negative 1 squared. So plug in negative 1 for every x. What is negative 1 squared? Positive 1, right? Negative times a negative. Minus 2, minus 1. No, 1 minus 2 is negative 1, minus 1. So my vertex will be when x is negative 1, y is negative 2. Negative 1, negative 2. Where can I put one more point on this graph? Negative 2, negative 1, because we know it's a mirror of that intercept that we found. And then we connect our points with the u, put our arrows, and there is a little sketch of the graph of this function. So we don't forget about it. Domain is what? Negative infinity to positive infinity. Good. Negative 2 is where my range starts. That's my lowest y value. It's in brackets to positive infinity. That when you see any of these words, if it asks you to find the roots, if it asks you to find the solutions, if it asks you to find the zeros, they all mean the same thing. You are finding the x-intercepts. Okay, so sometimes it'll just say solve. That means find the roots or find the x-intercepts. That's why when we do our graph analysis on our calculator, when I ask you for the x-intercepts, you do a second calc 0 because that's another name for the x-intercepts, right? So quadratics can have either two solutions, which would look like this. So two places where it crosses the x-axis. They can have one solution, meaning the vertex hits the x-axis at one point, or it is possible they have no solutions where it never hits the axis. 2, 1, or 0 roots or solutions or whatever you want to call them. To solve, the way that we solve a quadratic is we get it in standard form. Standard form. Set it equal to 0 and then solve for x. Those x values will be your roots, your solutions, your zeros, your x-intercepts, all the same. Okay? A lot of times what we're doing when we're solving for x is we are going to factor. And that's why we've been reviewing factoring from the beginning of the first day of school. Okay? It says find the roots. It could also say find the solutions. It could also say find the zeros. It could say find the x-intercepts. So what we are going to do is set this equal to 0. So plug in a 0 for f of x. Make sure it's in standard form. It is. And then we can factor. So I like the x. Okay, then we do our x method. On the top, a times c. So negative 12 times 1 is negative 12. And on the bottom is our b value. Then we figure out what two values multiply to equal negative 12, but add 6 and negative 2. Attention, because we pull directly from our x and we set up our factors. X plus 6 times x minus 2. And then we set each of these equal to 0 and solve. So we have two places where this graph will cross the x-axis at x equals 6 and at x equals 2. Yes, because you have to set it equal to 0 and solve. So this one should say negative 6. Erase the whole thing. So x plus 6 equals 0. X. Those are x-intercepts. Yep, so those would be right along your x-axis. If, look at number 2, you must be aware of your a value when you are doing your factoring. The first thing you want to check for is, can you factor out a GCF? Is there a common factor that I can pull out of all of these? No. So I go right into my x method. A times c, negative 9 times positive 2 is negative 18. And then my b value is 3. So what are my two numbers that multiply to negative 18, add to negative 3? Yes, 6 and negative 3. These multiply to 18, they add to positive 3. Because a was not 1, we need to divide both of these by a and simplify. So this simplifies to 3. This does not simplify further. Our two factors set equal to 0 will be x plus 3 And then bottoms up the fraction, 2x minus 3. Do not leave the fraction in your factored form. It is not fully correct. To get the actual values at x when we want our zeros, we set each of these equal to 0, so each factor equal to 0. So one will happen at x equals -3, and the other one will happen +3 plus 3.
3 over 2.
Yes. So x equals 3 over 2. So our two zeros occur at those two places. If you have a GCF, you have to pull it out first. Otherwise, your math isn't going to end up correct. So divide everything by 2. And then you do your x method only on what's inside the parentheses. So we get 9, -6, 2 -3s. So -3 times -3, which gives us our two factors, x minus 3 times x minus 3. The 2 is still out here, but it's not going to affect our intercepts. The 2 affects our stretch or shrink, but it doesn't affect our intercepts. So then if we set each of these equal to 0, we're going to get the same root twice. So what happens is, what this looks like on graph is it's one of these where it has one value. So we have one x-intercept. That repeated root means that its vertex is going to happen at the x-intercept. Okay, so then this last one, we check to see if there's a GCF we can factor out, and there is not. So we just go right ahead with our x method. -6 times 6 is -36, and our b value is 5. So our two factors are 9 and -4. And then, because a was not 1, we have to divide each of these by 6 and simplify. So 4 and 6 are both divisible by 2. -2/3 is what we will use to get our factors. And then 9 and 6 are both divisible by 3. So setting this up, bottoms up, start with the one on the left, 2x plus 3, and then 3x minus 2, set these equal to 0. Set each equal to 0, and solve for x. -3, and then x equals -3 halves, and 3x minus 2, x equals 2/3. So those would be our two x-intercepts. So then this last page is more like what you'll be expected to do. So to find everything basically about the graph when you're just given the equation. So solutions, x-intercept, remember solutions are x-intercepts and the y-intercept and the vertex. So we have a quadratic in standard form. We can see, first of all, from standard form that our y-intercept is going to occur at +10. So we can graph that point. Then let's do our solutions, which means we are going to factor. So 10, -7, -5, and -2. Oops, just do that correctly, -2. So we get x minus 5, x minus 2, set equal to 0. Set each of these equal to 0 and solve. So we have 1 at x minus 5, and 1 at x equals 2. So +2 and +5. Those are my two x-intercepts. Then I need to find the equation of my axis of symmetry. So x equals -b over 2a. -b would be -7 over 2 times 1 is a. So we get 7 over 2, which is the same as 3.5. So my axis of symmetry is at x equals 3.5. So halfway between 3 and 4. To find where my y coordinate of my vertex is, somewhere along that 3.5, I take this and I plug it back into my original. So I get 3.5, so plug in 3.5 for x, minus 7 times 3.5 plus 10. So 3.5 squared, 12.25 minus 24.5 plus 10, and when I do all that math, I get -2.25. So my vertex is going to be at X equals 3.5, Y equals negative 2.25. So that's just a little bit below negative 2. And then I can connect my points with a nice smooth parabola and arrows at the end. Number 5. First thing I can see is that my y-intercept is at positive 5, so I'll put that there. And then before I keep going, I have to factor out a GCF of negative 1. You always want your a value to be positive when you're doing your x method. So first let's factor out that negative 1, which just changes the sign of every term and makes sure that our a value is 1. Then we're going to do our x method on just what's inside of the parentheses. So negative 15, positive 2, this would be 5 and negative 3. And then because a was not 1, we divide both of these by a. So our two factors are bottoms up, 3x plus 5 times x minus 1, set equal to 0, solve for each. So x equals negative 5/3 and x equals 1. So positive 1 and then negative 5/3, which is about negative 1 2/3. So like kind of here, something like that. Again, it's not super easy to see our axis of symmetry, so we'll go ahead and just do the math. Negative b over 2a, so negative b would be negative 2 over 2a. A is negative 3. So this gives us 2 over negative 6, which is negative 1/3. So the x coordinate of our vertex is negative 1/3. So we know we have our axis of symmetry like here. To find the y coordinate of our vertex, we have to plug in the 1/3 back to our original. And because this is going to be a repeating number with a fraction, I want you to use the fraction rather than the decimal to get an exact answer. So we'll do negative 3 times, plug in negative 1/3 for x. Okay, to square our fraction, we square the top, the numerator, we square the denominator, and it will become positive because a negative times a negative. 1 squared is 1, 3 squared is 9. We'll do this multiplication. This is 2 over 1, and it's a negative times a negative, so this will be positive. So 2/3 plus 5. And then multiply this, so negative, I'm going to get rid of that. 3 over 9 plus 2 over 3 plus 5. This simplifies negative 1/3 plus 2/3 plus 5. We can combine these two. So negative 1/3 plus 2/3 is positive 1/3 plus 5, meaning our y coordinate of our vertex is at positive 5/3. So the vertex is at negative 1/3, 5, and 1/3. That is our vertex. And we can graph that, erase this line going through here. Okay, so we can graph that negative 1/3 and then positive 5 and 1/3. So it's just a little above the y-intercept. And then that's our vertex, and then it starts going down. So that is a sketch of our function when we have all of those pieces with the vertex and the intercepts and x and y intercepts.